All right, so here we are with right angle trig, which is our chapter 10 from Algebra 2. So, some of you should have experience with trigonometry because it's mainly started in geometry. So hopefully you have that. But we're going to go over the basics here. So a trig function is a function whose rule is given by a trig ratio. And of course, ratio is your fraction. So anytime that you ever see the word ratio, especially in your mathematics here, you're going to actually be thinking of fraction. All right. So then a trig ratio, or again, fraction, compares the lengths of two sides of a right triangle. So again, in a right triangle, there's of course your hypotenuse, and then the other two we call legs. So most specifically for a trig function, we have the trig function sine, cosine, and tangent. And even though they are not necessarily very long words, especially sine, we do abbreviate sine, cosine, and tangent as SIN for sine, COS for cosine, and TAN for tangent. And you will find those on your calculator as well, or any other scientific calculator, so they're here. Generally, when you're doing this, you are going to want to be in what we call degree mode. So if you click your mode, you should not be in what they call radian mode, but you should instead be in degree mode because most likely you will be referencing a degree. So the next thing that we're looking at here is the fact that each of them equal a fraction of a certain set of lengths of a triangle. So the idea is that there is some sort of theta angle. Okay, so let's pretend that we are talking about this angle as theta. We could also be talking about this angle as theta, but they are going to always be, theta is always going to be one of what they call the acute angles, okay? Because it can't be this angle here. Okay, so theta is never going to be sitting here on the right angle because we always know that that's there and it's 90 degrees. So another thing that we always know is that across from the 90-degree angle is always your hypotenuse. And so when our trig ratios kind of reference a hypotenuse, it's always across from the 90-degree angle. But then something changes because we don't necessarily call this leg and this leg. So when you're looking at this angle measure here, anytime that you are thinking about where your angle is, you're imagining that you're standing there. Okay, so if you were standing up here, the side that is opposite to where you are standing would be over here. So this one we call the opposite. This one here, for the word next to, we're going to use adjacent. Okay, and so again, if you are standing up here at the angle that's given, okay, your opposite side is across from you and your adjacent is next to you. However, let's say that you move around a little bit and now your angle is over here. If you're standing over here, this is no longer the opposite side to where you are. This is the opposite side. And this is the adjacent side. So basically, every time that you are doing this, you're going to want to go ahead and label them. So you're going to want to identify where is the angle that you are standing. Okay, and again, never on the 90-degree angle. Identify your hypotenuse, and then from where you're standing, identify the opposite side and then the adjacent side. So once you figure out how to do that, then you can go ahead and fill in each of these ratios. So the sine of an angle is the ratio of the opposite leg to the length of the hypotenuse. All right, so that's sine, opposite, and hypotenuse. Cosine is the ratio of the length of the adjacent side to the hypotenuse. And tangent is the ratio of the opposite over the adjacent. All right. So a mnemonic device here for remembering this is Sohcahtoa. So if you're ever told that, that is because the idea is that in so S represents sine, and the fact that it equals opposite, guess I'll do it in another color, over hypotenuse. The next one is ca, which stands for cosine. And cosine equals adjacent over hypotenuse. And then the last one is toa. And again, that's because T is for tangent. And that equals opposite divided by adjacent. So the mnemonic device, or the memory technique here, is remembering this in order to remember which things create fractions in trig. So a lot of times people will just write this at the top of their paper so that you can kind of reference it as you're thinking of what is equal. All right, moving on to our first example here. All this is asking for is not to necessarily solve anything, so we don't necessarily need a whole lot of the calculator today. We're just going to find the value of the sine, cosine, and tangent functions for theta. So we don't have any theta here, and so we're just going to use that as the variable, and everything else is going to be filled in. So taking a look at this image here, notice, of course, we have the right angle, and so across from the right angle is your hypotenuse. So anytime that we are talking about the sine, for instance, which uses hypotenuse, and the cosine, which uses hypotenuse, we're going to be using the number 39. Another thing to reference is that you are standing over here because of the theta angle right there. And so you're going to say that the opposite is, of course, 15 across from where you're standing. And then the adjacent is 36. So as we set up each of these tangent functions, remember that the idea was, especially from Sohcahtoa here, that sine of some degree, which we don't know what it is equal to the fraction of the opposite over the hypotenuse. So that means if I'm going to fill this in, that the sine of theta, and I usually put parentheses around whatever's inside of the sine, just because otherwise you might think that something's added or whatever. And we're going to set that equal to the opposite, which is 15, over the hypotenuse, which is 39. And so that is the sine function for theta. So then we can do the next one. So that's just sine. So the next one is cosine, and cosine is represented by cos. And cosine of theta is going to equal our adjacent over hypotenuse. So we need our adjacent value, and we'll put it over the hypotenuse value. And so cosine of theta is going to equal the adjacent value, which we've said is 36. And the hypotenuse value, which we've already used, but it's 39. If you can reduce these fractions, it's nice to do that. So 36 39ths could also be reduced by at least 3. So 12 13ths could also work. It's just that sometimes it's actually easier to keep it in the numbers that you have, because then you can set them back into the triangle. So kind of get to choose if you want to reduce or not. And then the last one is tangent. And again, tangent is represented by TAN for a little abbreviation. And that's going to equal your opposite side over your adjacent side. So no hypotenuse in tangent. So tangent of theta is going to equal the fraction of the opposite side, which is 15, over the adjacent side, which is 36. And again, if you feel like reducing, you can, but we're just going to keep them the sides that we have. All right, so that's example 1. Moving on, we have another idea to introduce, and that is your special right triangle. I don't focus a lot of time on this in our geometry class, just because you can actually just do this with trig anyway. So you don't necessarily need to have this memorized, but it will show up on lots of formula sheets, so you may as well know how to interpret it. But the idea is that there are some special triangles. For instance, this one here, a 30, 60, 90, actually comes from the fact that you could give its other side here. And if you do that, you end up with a 60, 60, 60, or an isosceles triangle. Okay, so the idea is that if you have an isosceles triangle, which does show up a lot in math, you cut it in half, and now you have a 30, 60, 90. And if you want to very quickly figure out, for instance, the height of this isosceles triangle, you would just take half of one of the side lengths and multiply it by the square root of 3. So that is why, of course, here x is only half of this length, because the other length would be another x, which is why this side says 2x, because this side length and this side length in a equilateral triangle would be all 2x. And so if that's only x, then this is x. Together they'd be 2x. So anyway, 30, 60, 90 triangles pop up a lot. Also 45, 45, 90 triangles. And that's because these are isosceles triangles. And this one is half of an equilateral. Okay, so either way, hopefully you can see that if you have these two base angles that are the same, then of course the side lengths are the same. And then over here, to find the hypotenuse, which you could just use trig or you could use Pythagorean theorem, would be x times the square root of 2. So this is just multiplying. It's going to give you a decimal. So there are two examples here underneath that use these exact formulas. So one other reason for trig that I haven't quite mentioned, the trig idea is because you are only given one side length. And because you're only given a side length and an angle, you can't actually use Pythagorean theorem. So that whole a squared plus b squared equals c squared thing, as much as we love that with right triangles, we are not able to use that in a triangle like this because we only have two sides and one of them isn't even a number. Okay, so one side with one side length and one angle means that there's going to be trig involved. So in this one, we are going to go ahead and use the trig to find the value of x. So taking a look at this angle here, this is what we're going to call our theta. And so that means that we are standing at this angle measure. Okay, so two things that we can do. We can actually do the trig to figure it out, or we can recognize that if this is 60 and this is 90, then the only other measurement would be 30, and so therefore we have a 30, 60, 90 triangle. So on that note, we can then say that if this is 2 of our x value, and this is 1 of our x value, x squared is 3 of our x value, that we could just take that 50, which would be half of 100, and multiply by square root of 3 to get x. So we'll do it both ways. The first way is going to be with the actual trig identity, and the second one is going to be using the 30, 60, 90 triangle. So here we are with our trig identity. And so the trig that we are going to use covers the fact that this has an opposite side length that we are referencing. So this is your opposite. And we have an adjacent side. Adjacent is over here. This is the hypotenuse. I'm going to write it in red because we're not actually going to use it. Notice that the adjacent side, standing next to where you are, doesn't have a variable and doesn't have a measurement. So as much as we love that we are labeling all of them, we're not going to use the adjacent side, which if you reference back to our first page of notes, looking at all of the fractions, the one that doesn't use adjacent, right? Adjacent and adjacent are in both of these, is sine. And so the way that we pick which 3 that we are going to do, which of the 3, is by looking at what we don't have. We don't have an adjacent length or anything to mention the adjacent length, and so that means we're not using tangent and we're not using cosine because they would have referenced it. So in that case, we're going to use sine, and sine of our angle is equal to the opposite, which I will abbreviate op, and hypotenuse, which I'm abbreviating hip. And so now I'm going to plug in all the things that I know. So I know that theta is 60, I know that the opposite is x, and I know that the hypotenuse is 100. So that means that I'm going to write sine of something equals a fraction. And that something is going to be 60 degrees. And the fraction is going to be opposite, which is x, over hypotenuse, which is 100. So anytime that you have this type of problem that you are trying to solve, you're trying to get x by itself, and x is being divided by 100. So to solve, I'm going to multiply both sides by 100, which will cancel that one and give you x. And then if I multiply this by 100, that actually is just a digit. So going to your calculator, you're going to have sine, which is this one here, and of 60, and I guess I could do it in the right order. This is going to be written as 100 times sine of 60. And you do not actually, that was a 60. You do not actually need to put a degree symbol in there. There is one under the math key, but as long as you are in degree mode, it doesn't actually need to have that degree symbol. So 100 times sine of 60 is going to give us what our x value is. And our x value is 86.6025. So that's the answer using the trig identity. And now we're going to figure it out using, let's find another color. Now we're going to figure it out using the 30, 60, 90 triangle. And so you're going to see that, yes, you could use it with trig, but sometimes it's nice to be able to reference these triangles. And they are actually called reference triangles. So there you go. So to use the 30, 60, 90 method, all you need to do is identify what you have. So over here we have 100, and that's the hypotenuse, and we have 2x, and that's the hypotenuse. So of course the two hypotenuse are going to equal. So that means that 2x from the diagram is going to equal 100 from the actual problem. So we've set our hypotenuse equal, and so we can divide by 2 to both sides and get an x of 50. Now, unlike our previous problem, that's not actually the answer. The answer, because we're actually solving for x of this one, is to take that value and multiply by the square root of 3. So if we want to find the opposite side length, we're going to need x times the square root of 3. And since we just said x was 50, that means that we're going to have to take 50 and multiply by the square root of 3. And turns out that 50 times the square root of 3 is going to result in the same value that we had from the previous one. So 86.6025. So it just depends on if you understand how to use your reference triangle and match up the hypotenuse with the hypotenuse, and then how you're finding the height here, or if you would rather set up a trig identity. So then we have our last example here of using a trig function to find the value of x here. It's side length of a 45, 45, 90 triangle. Again, I don't necessarily know that this is 45 because it's not written, but 180 minus 90 minus 45 does tell me that that's a 45. So I'm going to, again, do it in 2 different ways. I'm going to do the first way, which is using your trig identity. And with the trig identity, remember that this is your theta, or where you're standing. And so that means that this is the hypotenuse. This is the opposite. And this one over here is the adjacent. And just as before, the hypotenuse equals something, the opposite is equal to something, but the adjacent has no variable or no number there. And so we are going to use, again, sine, since sine is the one that doesn't use adjacent. So we're going to fill in sine. And remember that sine is equal to opposite over hypotenuse. And you do not want to flip those accidentally, so make sure that you remember Sohcahtoa. So O is first and then H. And so we'll do sine of our angle measure, and that will equal our fraction. The angle measure is 45, and the fraction is x over a hypotenuse of 20. Looking back at our previous one, or understanding solving equations, I'm just going to multiply both sides by 20 to cancel that 20. And then this one by 20 will result in the digit that x equals. So I'm going to do 20 times sine of 45. So there's our value, 20 times sine of 45. Press enter, and now we know that that side length is 14.1421. All right, switching to the other idea of using the 45, 45, 90 triangle. If we use this idea, that means that we need to understand that if 20 is the hypotenuse, 20 equals x square root of 2. So the hypotenuse is equal to the hypotenuse, which means that 20 from the diagram is equal to 20 from the reference triangle. So if 20 equals x times the square root of 2, we can go ahead and solve for x by dividing by the square root of 2. If you divide by the square root of 2 to the right side, you'll cancel it. But to the left side, 20 divided by the square root of 2 leaves you with the number we just got before, 14.1421. All right, and this one we don't necessarily need to multiply by 2 or divide by anything because x is the length of the side, just as it is up here. But in the previous one, we were trying to find the height, and that equaled x square root of 3. So we did need to multiply by square root of 3 to get our answer. All right, so that's what you're going to be expected to do in the assignment. And of course, if you don't understand some of the assignment problems, there will be a video for that.